All right, so if I'm doing these ones, I'll do the first ones a little bit slowly, and then I'll do some of the kind of last ones slowly as well, just because they're a little bit of a different form. So if all I care about is the end behavior, right? I don't care about what this function is doing kind of in the middle. I just care about what this function does kind of like all the way at the fringes, right? This means what does this function do as x gets closer to infinity and x gets closer to negative infinity. All right, so only things that I care about are going to be the lead coefficient and the degree. So if I look at this function, right, my degree and my lead coefficient, well, the highest power of this function is going to be 2. So my degree is 2. It's an even number. My lead coefficient, I don't care what the number is. I just care that it's positive. So who knows what this thing looks like in the middle? I mean, we all know what this thing looks like in the middle. It looks like a parabola. But kind of end behavior, even function, we have not flipped it. So positive, positive. So as x approaches negative infinity, we're going to approach infinity. As we approach negative infinity, we're going to approach infinity as well. So if I look at this second example, right, so same idea, we would say, okay, well, let me find the degree of the function. Highest power is 3. So this is a third degree function. It's a cubic. My lead coefficient, I don't care what number it is. I care what sign it is. So it's negative. So normally, my third degree odd function would look like this. So this would be like x to the third power. So what happens? If I reflect it, it's going to look like this. So this is going to be like a negative x to the third power graph, or any negative x to an odd number. All right, so then what happens as we go off towards negative infinity? Our function's now shooting off towards infinity. What happens as x approaches positive infinity? Well, now our function's going off towards negative infinity, right? Notice what happened, right? For x cubed, it would be negative infinity to positive infinity. We flip it, so it's infinity to negative infinity. All right, so I'll do these ones kind of quick because these ones are pretty much the same. All right, so if I look at this one, right, so seventh power, so it's odd. Our leading coefficient is positive, right, because there's nothing there. So just like any odd function, it's going to go off towards negative infinity and with positive infinity. All right, so negative infinity to positive infinity. I have x to the fourth power, so I'm a fourth degree function. My leading coefficient is negative, so it would flip. So normally we go infinity, infinity, so we're going to flip and look something like this. So we're going to approach negative infinity and also negative infinity. So if I look at some of these other ones down here, now we have things that are in factored form. So got to be a little careful. So if I look at what my degree is, right, I have an x here and an x there. If I were to multiply these two x's together, I'm going to get x to the second power because x times x is x squared. So this is going to be a second degree polynomial. Lead coefficient, well, this is positive, that's positive. If I multiply two positives together, I'm going to end up with a positive number. So this is just going to be a regular old quadratic, infinity to infinity as its end behavior. So next one, it's kind of the opposite, right? So I still have an x times an x, right? So that's going to be a second degree polynomial. Positive, positive, I have a negative out front. So this is going to be a negative times a positive times a positive. One negative means that we're going to be a negative. So we have a flipped quadratic. So we're going to approach negative infinity and another negative infinity. For m of x, little trickier, right? I have an x squared and I have an x. So I have x to the second power times another x. So this means my degree is going to be 3. My lead coefficient, well, I have a positive, and I have a positive 1 out front. So it's going to get a positive lead coefficient. Right, so this is just going to be a regular old cubic. So we're going to approach negative infinity and infinity. And then finally here, let's see, we got a x squared. Like I have an x squared and I have another x squared. So that's going to be a fourth degree polynomial. Quartic, I have a negative, and then, well, these things will be positive anyway because we're squaring them. So I just have a negative out front. So I have a negative lead coefficient. So this is going to be like a reflected quadratic. It's going to be a little bit boxier at some point. Actually, this might do some flips or something along the way. But the thing we care about is end behavior. And this thing is approaching negative infinity on both sides.